Again, dear students, and welcome to today's video tutorial where we'll be looking at the GCE 2023 proposed solution for pure mathematics with mechanics paper 3. The question we are looking at is a question on center of gravity, and the question reads: the figure shows a uniform rectangular lamina ABCD of side 8A and 4A, a square AGFE of side 2A, and a circle of diameter 2A with BC as tangent at its midpoint H are removed from the rectangular lamina. Find 1. The distance from AB and AD of the centroid of the remainder lamina. 2. Show that the tangent of the angle of inclination of AD to the vertical when the lamina is suspended freely from D in equilibrium is 124 minus 7 pi divided by 52 minus 2 pi. Now, in this figure, we have a rectangle ABCD in which a square AGFE and a circle with radius A have been removed. Now, we are asked that let us find the centroid of the remaining lamina. What is the position of the center of mass of the remaining lamina when these two shapes have been removed? Now, to begin with, I will let x bar, y bar to be the position of the centroid from the sides AD and AB, and lambda be the weight per unit area. Here we are assuming that the weight is evenly distributed in the lamina, and therefore to obtain the weight of that lamina or the weight of the portion, I will need to find the area of that portion and then multiply it by the weight per unit area, which in this case we let it as lambda. Now, this is a shape that we are working with, and I will indicate each position of the centroid of this square, the rectangle, the circle, and then use it to find the position of the centroid of the remaining lamina. Now, the centroid of a square is rather easy because the centroid is at its center. So, the centroid of the square will be at the point A, A, that is distance A from the side AD and distance A from the side AB. Now, the centroid of the rectangle as well is also at its center. Remember, the rectangle here is the whole rectangle when these shapes have not yet been removed. So, the centroid will be at the center, that is half of the distance 8A and half of the distance 4A. So it will be somewhere here. So this is the centroid of the whole rectangle 4A, 2A, because it's 4A from the side AB and 2A from the side AB. Now let me move on to the last shape, which is the circle. The centroid of the circle is at its center, but we are taking the centroid, or we are measuring that distance from the side AD. So if from the center to the point H is A, then the remaining distance, which is 7A, will be the x-coordinate of the centroid of this circle from AD. And of course, since H is a midpoint of CD, so the y-coordinate will just be half of 4A, which is 2A. So the centroid of the circle will be at point 7A, 2A. Now let x bar, y bar be the centroid of the remaining lamina when the square and the circle have been removed. Now I'll draw a table where I will represent all this information concisely. On the table and on the header of the table, I'll be having the portion. Which portion am I working with? Then I find the weight of that portion, the x-coordinate of the centroid from AD of that portion, the y-coordinate of the position of the centroid from AB, and then I'll find the moments of that weight about AD and the moment of the weight about AB. So I'll have 4 portions to work with here. The first portion will be the square, the second portion, the circle, the third portion, the whole lamina, and the last portion, which is the portion of interest, the remaining lamina. Now let me start with the square. The weight of the square will simply be the area of this square, side times side, 4A squared, multiplied by lambda. So I have 4A squared lambda. And the x-coordinate of the centroid from AD was A, and the y coordinate is A as well. And the moment of that weight about the side AD will be, I take the weight and I multiply it by the x coordinate of the centroid, which will give me 4a cubed lambda. And the moment of that weight about the side AB will just be the weight multiplied by A, which is 4a cubed lambda. Moving on to the circle, the weight of the circle will be the area of this circle times lambda. Area of a circle is pi radius squared. So the area of this circle will be pi a squared then times lambda to obtain the weight. And the x coordinate of the centroid 7a, y coordinate of the centroid 2a, and the moment of that weight about the side AD will be pi a squared lambda times 7a. That gives me 7 pi a cubed lambda. And the moment of that circle about the side AB will just be the weight times the y coordinate of the centroid, which will be 2 pi a cubed lambda. Then moving on now to the whole lamina when these two shapes have not yet been removed. So the weight will be the area 8a times 4a, that is 32a squared lambda. And the x coordinate, of course, was 4a, y coordinate 2a. So the moment of the whole lamina from the side AD will be the product of the weight by the x coordinate. That gives you 128 a cubed lambda. And the moment of the whole lamina about the side AB will be 64 a cubed lambda. We are multiplying the weight by the y coordinate of the centroid of the whole lamina, which is 2a. Now, this is our portion of interest, the remaining lamina. So the weight of the remaining lamina will be the weight of the whole shape minus the weight of the square and that of the circle. So I will subtract these two weights from the weight of the whole lamina to obtain 28a squared lambda minus pi a squared lambda. Now the x coordinate of the centroid is what I'm looking for, x bar, y coordinate, y bar. Now to find the moment of the remaining lamina, I'll need to use the principle that the moment of the removed part plus the moment of the remaining part is equal to the moment of the whole lamina, which means the moment of the remaining part would be the moment of the whole part take away the moment of the removed part. So to have the moment of the remaining part here, I will need to subtract the moment of the removed part, that is the moment of the square and the circle, from the moment of the whole shape. So doing the subtraction, I'm left with 124 a cubed lambda minus 7 pi a cubed lambda. Doing the same thing here, that is subtracting the moment of the square and the moment of the circle from the moment of the whole lamina, I get 60 a cubed lambda minus 2 pi a cubed lambda. You can do the subtraction and verify. Now, to find out the x coordinate of the centroid of the remaining lamina, I have to take moment about AD because that gives me the x coordinate. And x bar would be the sum of the moment about AD divided by the sum of the weight. And the sum of the moment about AD, I had it as 124 a cubed lambda minus 7 pi a cubed lambda divided by the sum of the weights, 2100. I'm sorry, this should be 28 a squared lambda minus pi a squared lambda. Now, a cubed lambda is common to the terms of the numerator, and a squared lambda is common to the terms on the denominator. And I can factor out those, and then lambda cancel out with lambda, a squared cancel out a squared, I'm left with a. And so the x coordinate of the centroid of the remaining lamina would be a into 128 minus 7 pi divided by 28 minus pi. Yes, I've rectified the error here. Now, doing the same thing, I'll take moment now about AB in order to find the y coordinate of the centroid of the remaining lamina. So y bar will be the sum of the moment about AB divided by the sum of the weights. And this is where I will take my result. So I'll be having 60 a cubed lambda minus 2 pi a cubed lambda divided by the weight, 28 a squared lambda minus pi a squared lambda. I do likewise the previous by factoring a cubed lambda from the numerator and a squared lambda from the denominator. And I get this, lambda takes care of each other, a squared goes into a cubed a times, and y bar will be a into 60 minus 2 pi divided by 28 minus pi. So I have had the centroid of the remaining lamina. I have the x coordinate and the y coordinate, x bar and y bar. Now, the next question is that the lamina is suspended from the point D. Let us find the tangent of the angle that it makes with the vertical. Now, the principle here is that when a lamina is suspended from a point, it will naturally come to rest in a position where the center of gravity is vertically below the point of suspension. So to solve the problem, I will just need to draw a line from the point of suspension to the position of the centroid of the remaining lamina. So I will draw a line from D, since it's suspended from D, right to x bar, y bar, because that is the centroid of the remaining lamina. And I complete a right angle triangle and I indicate the angle. Here we are looking for the angle that it makes with the vertical, and this is the required angle here. So to find the tangent of that angle, I need to find the ratio of the opposite length to the adjacent length. And the opposite length, of course, is this distance, which is x bar, and the adjacent length is not x bar, is not y bar, I mean to say, because y bar was measured from the side AB. So the opposite to this angle is x bar, and the adjacent to this angle would be the whole distance 4a, take away y bar. So what I'll be solving now, what I'll be evaluating now is that if theta is the required angle, then tan theta will be x bar divided by 4a minus y bar. So let me evaluate the denominator first and find 4a minus y bar, which is equals to 4a minus, this is y bar. So the LCM is 28 minus pi divided by 1 times 4a gives 112a minus 4 pi a minus, I distribute this negative 1 into the bracket. I have negative 60a plus 2 pi a. Bringing like terms together, 112a minus 60a gives 52a. Then negative 4 pi a plus 2 pi a gives negative 2 pi a divided by 28 minus pi. So that is the value of 4a minus y bar. Now let me take this back into the formula to obtain the tangent of that angle. So tan theta will be x bar, which is this quantity, divided by 4a minus y bar. So if I exchange it to multiplication, I have to find the reciprocal of this fraction. So I will now have 28 minus pi divided by a into 52 minus 2 pi. Now 28 minus pi strike off with each other, and I'm left with an a as well, take care of each other, and the tangent of the angle of suspension at D would be 124 minus 7 pi divided by 52 minus 2 pi. Now we have come to the end of this presentation, but if you do have any complaints, any problems or corrections or doubt, please do leave it in the comments section below. Until then, I am Tata Ernest, and have a splendid day.